Good afternoon.
Good afternoon.
Let's see. I can't see anybody in Mogollon. Oh, there you are.
The camera's really high. I'm gonna get Miss Townsend and see if I can change that.
Okay, that would be wonderful. Okay. All right. So, how's everyone?
Good.
Good to hear. Okay. So let's see. So who's missing in St. John's?
Aiden.
Aiden. So is he gonna be in or?
No, he's at the soccer tournament.
Okay. Yeah, he was trying to take some stuff this morning. I know he was emailing me. Let's see. How about there's Jordan, and everyone is present in Mogollon, right?
Yeah, everyone's just in the room over finishing their test.
Right. Okay. Yeah. So, we did want to talk a couple things about that. And then Winslow, is everybody there? I think so.
Yeah.
Awesome.
Mr. Strong,
Yes.
Hannah Z's actually gone today,
Oh,
I think.
okay.
I think she has volleyball.
Okay. Yeah, I think she took her stuff this morning, though. Or no. No. Anyway. Okay. I'll mark her absent, and then.
Actually, no, she is here.
She is here. Okay.
I don't know. Jordan said she wasn't, but she is.
Okay. All right. Well, thanks for looking out. Okay. So, a couple of things, though, before we get started, that, issues that go on the fly. Let's see. So let's see. Let's see. I know Miss Townsend's there in the next room. Let's see. Shauna, are you there?
No, she's not here. We messed up today.
Okay. And then, let's see. What about in, let's see, St. John's? Is your talent aide there?
Yes.
Okay. All right. So just a couple of issues that I've already talked to Ms. Townsend about, that just in case, okay, things happen. So today at Mogollon, and they're in the middle of taking their tests and quizzes and stuff, and so their internet goes out, all right? And it's a time test, right? So what do? Well, what you do is you try to contact me. And so what I was able to do with them is give them an extra 10 minutes at the back end. And so that's why they're kind of trickling in, is because they take their tests and quizzes in the library and then come in. So it worked out okay. But if that would ever happen, just know, don't freak out. It'll be okay. We'll work it out. The second issue that came up today is that for at least one student, maybe two, is that there was a weird formatting error on the test or quiz. Okay? Let me tell you why that happens is usually because your school hasn't updated their browsers. Okay? So my number one recommendation for you is to do all your tests and quizzes in Firefox. Okay? So run the Firefox browser, because Firefox seems to be able to handle it even if you don't have the latest Firefox browser. If your school doesn't have Firefox, then just have, if the Talon Lab aides, if you would ask that they, whatever computers they're going to be using, that you guys are going to be using to take your tests and quizzes, make sure it has the latest browsers on it. because we ran into that issue a little bit last year as well. So Firefox is the preferable browser on this. So, any questions, concerns?
I forgot to email you, but my Moodle still isn't working.
Okay. Have you tried it in the last hour?
Yeah, I just tried it right now.
Okay, so here, what you're gonna need to do is, because I went through and I made sure that the quizzes were open for you and all this kind of stuff, and so I verified everything this morning just to make sure that you were cool. And so if that's why I was saying, if you hadn't tried it since I did all that, then maybe it would be up to date now. But if you have tried it and you're still not working, then you're going to need to call the support. And
Okay.
so it has the number on there, but I can tell you what it is if you want to write it down.
I think I have it right here, actually.
Okay. So
Yeah.
just tell them what's going on, and they can go through it.
All right.
So,
Cool.
here's my guess is that when they were, if yours isn't working and everybody else's is, my guess is when they they registered you, they forgot to check some box.
Okay.
So they just go in there and check the box and you're good. So,
Alright.
but in the meantime, any quizzes or whatever that you've missed, just let me know when you can take those, and I'll reopen them for you. Okay?
All right.
No worries.
Sounds good.
Okay? All right. Any other issues anyone wants to report? Okay. So we'll,
Mr. Strong,
yes.
are you still going to open the quizzes for today? For
Okay.
us?
So, yeah. So let's see. So I have that Winslow, that you're taking them after class. So yeah, they'll be open, and then but you didn't want me to open. So I've got and then the ones from last week I'm also going to open for you guys. But I have that you didn't want to do the test until Friday, which because you've got 2 to make up. I mean, even though they're only like 5 or 10 minutes, I think it'd be good to. I've got the quizzes all ready for you guys right after class, and then Friday at 2:30 is to open up the test. Is that still good? I'm just going.
Can we our Miss Lopez isn't here today, so we have a sub. So we were wondering if we could just take the quizzes tomorrow after class and still take the test at the same time.
You mean have everything on Thursday?
No, just do the quizzes on Thursday and the test on Friday.
Oh, okay. Yeah, that's okay with me, as long as she can stay or whatever.
Yeah, I think
it's-
that's fine.
Okay. So I'll go ahead and do that. I'll have. Are you sure you don't want to do like 2 today and 2 next time, or you want to just do them all 4 tomorrow?
Yeah, we can do 2 today and 2 tomorrow if you want.
Okay. So why don't we do that? And so the other 2, the 1-3 and 1-4, it'll say that it's open or whatever, but don't worry about that. I'll just open them up for tomorrow after school. Okay?
Okay, thank you.
All right, awesome. Then we'll be all caught up there. Okay, so and really anytime you guys, like, let's say tomorrow you wake up and you're puking or whatever. Okay, I mean, I'm not trying to wish bad things on you here, but if something happens, then if you'll just have your lab aide, Miss Lopez or Miss whoever. Your lab aide, if they'll email me or even text me or whatever and just say, hey, could you open up the quiz for Skylar today at 2:30 or something like that, I can. That's not a problem. But it helps me if like if Miss Moline or Miss Lopez or Miss Townsend are actually doing the emails for that, because then I know that they will be available to proctor at that time. Does that make sense? So if there's any changes, just have them email me and or text me, and that's not a problem at all. So we'll just kind of go with that. Okay. Any other issues or
So
questions?
for
Yes.
for St. John's,
Yes.
we did not take the quiz during 6th hour today, and quiz 1.3 says it closed at 2:50, and on mine quiz 1.4 says it closed at 11:50.
Okay. Well, isn't that when you told me to set it up?
I thought we were just going to do the test on Thursday during 6th hour.
Okay. All right.
For the quizzes due Wednesday, just after class.
Okay. Well, then we can do that. So you want so for St. John's, the quizzes. So whose is not set up to go after class?
Okay, so
So I have in my notes that you wanted the quizzes at 2:30, but so you're saying
Okay,
you
yeah.
don't want that?
no, I think we do. Sorry.
Okay. So just tell me what you want, and then you gotta follow through.
Okay,
So maybe
yeah.
while I'm writing it down, you need to write it down too, so that
Okay.
you know you're gonna do it. So
Yeah.
you want the quiz at 2:30, but you didn't do it at 2:30.
Yes.
We were still used to doing the quizzes after. Which would be
Okay,
like-
well that's fine. So do you want me to set it up for tomorrow at 2:30, or do you want to do it after class today?
We can do it after class today.
Okay. All right. So it might take me a minute to get that going, but so we'll do after class for the quizzes for all of you. I think Aiden might have taken his already.
Yes.
Yeah, I think you did.
Okay. All right. And then the chapter test, you're wanting to do the test on when?
On Thursday from 1:30 to 2:30.
Thursday from 1:30 to 2:30. Test for St. John's. Okay. All right. So I will adjust that. So if you go in there and it says, "Oh, the test is expiring today," whatever, don't worry about it. I'll fix that. Okay?
Okay, thank you.
No problem. All right. Anything else? Okay. Well, let's get back to it. I kind of feel like that this is just part of our growing pains here, and I hope it's not too stressful, but I think it's going to be okay. The thing that they're stressful, and then I guess I would tell you that. It's interesting that, today is, of course, September 11th, and I actually associate it with my with teaching calculus, because I was actually with a calculus class when the towers fell, and we watched it on TV together. I was like actually doing my planning period before, and somebody said, "Hey, turn on your TV," because the first tower had been hit. And so I'm actually with my my calculus class the next hour, and we were watching it. And so it was, I'm going to tell you something, for my parents' generation, it's like they all knew where they were when JFK was assassinated. But for me, it was in my generation, it's like, where were you? What were you doing on September 11th when the towers fell? And so my calculus class and I sort of shared that experience together, and anyway, it's kind of tough. But so little stresses like this that we're dealing with, that's nothing. That's nothing compared to what it could be. So anyway, I'm just grateful that you're all here and that we're all safe, and it just kind of adds a little perspective to what we're doing. So anyway, all right, well, today we are going to start with 2.2, okay, and limit of a function and limit laws. And so let me get set up there. Okay. All right. So we kind of talked about the need for a limit. And now we're going to kind of define it a little bit more and figure out ways to actually calculate a limit. Okay. So this is really the first really big topic in calculus, is finding the limits. Okay. All right. So if the denominator is 0 at a point C, try to factor and cancel. So this is going to be our very first way to find limits, is that if you can plug in, you can plug in. But if you can't plug in the number, try factoring. That's kind of the idea here. So let's say we want to know.
Mr. Strong,
Yes.
can we go over what exactly a limit is?
Okay, so, all right. So let me kind of explain it to you the way the ancient Greeks thought about it. There was a guy by the name of Zeno. And Zeno, he said that, okay, let's say I'm going to shoot an arrow at a target. And so the idea is that at some point in the flight of this arrow, it's got to reach halfway to the target, right? And then at some point, it's going to reach halfway again. And then halfway again, and halfway again. And so the idea is that you could keep taking whatever distance is available and cutting it in half. And so you could do that forever. So then theoretically, the arrow would have to pass through an infinite number of points, because you could keep cutting the distance in half forever. So Zeno then said, look, then if the arrow has to pass through an infinite number of points, it cannot reach its target. Yet, it does reach the target, and so that became known as Zeno's paradox. And so the idea of a limit is it's kind of like what Zeno was saying with the arrow, is it's got to go halfway, half the distance. The idea is that you can get as close to the target without ever getting there. So with a limit, we're saying that like as x approaches 0 or some other value, what does the function approach? And so what we talked about in the last section was the idea that it's like taking the slope at one point. And so that's kind of how we're going to look at it here today. So here, so in this, if I'm wanting the limit of this function, okay? So here, the function is x squared minus 1 divided by x minus 1. And I want to know, how does it behave near x equals 1? Well, it turns out there's a hole in the graph at x equals 1. So when I plug in 1, then what I'll get is 0 divided by 0. And so I can't get any information from my plugging in the number. So then the idea of a limit is that how about plug in numbers that are close to 1? So the idea that maybe like at 0.9 or 0.99 or 0.999, 0.9999, okay? So you just approach 1, and so that's what it means, is let x approach 1 and then see what happens. Now, there's going to be several ways that I'm going to teach you to find that answer, okay? One of them is to look at the graph. See, as x is approaching 1 from each side, just looking at the graph here, what does the y value seem to be approaching? At that, where that hole is in the graph.
2.
2. Okay? So that's the limit. So the limit is like the y value for functions. Now, the other way that we're going to do this problem is algebraically. And so what I'm saying here is if you try plugging in the number and you get 0 over 0, then see if you can factor and cancel. And so x squared minus 1 factors to x plus minus 1x plus 1. And then you cancel. And then when you cancel that term, you just get x plus 1. Well, now you can plug in 1 for x and get 1 plus 1 is 2. And so we got the limit over here without the graph. And then over here we got the limit with the graph without the algebra. And so that's 2 different ways that you can approach the limit. Okay? Now, a third way that you can do the limit is actually using the table feature of the calculator, where you say, okay, I'm going to approach 1, and as the x value gets closer and closer to 1, then you see the y value gets closer and closer to 2. And so that's kind of the idea of a limit too. And so that's actually 3 different ways that just in this first example that we can calculate limits, is with a graph, with a table, and then algebraically. Okay? Now, so Jordan, as we go through more examples, you'll get a better idea of the limit, but that's the idea of it, is that we're trying to figure out basically what's the function approaching. Okay? All right. So let's go to all right. So see if you can do this one. So you can either do it using algebra, you can use the graph, or you can use a table. So whichever way you want to do it, see if you can do this one. All right, Nathan, when you've got it.
Is it 2?
2? All right, I got 2 1/4, or 9/4, or 2.25. Okay, so let's go through it. I did it algebraically here. Okay, so if you try plugging in -2, then what you're going to get is a 0 in the denominator, and you can't divide by 0. So then here we try to factor. So the numerator factors to x minus 7, x plus 2. The denominator is the difference of two squares, so it factors to x minus 2, x plus 2. And then you can cancel the x plus 2's. So then you just have x minus 7 over x minus 2. And now you try plugging in -2 again, and you get -9 over -4. So 9/4 or 2 1/4 or 2.25 would be how we'd write that. Okay? All right, so you see where you made your mistake? Nathan?
Yeah.
Okay. All right. Any questions? Anybody want me to do it, tried it a different way and didn't get that answer?
Would we be able to do it the graph way?
Sure, but the limitations with the graph are is sometimes when you have an answer like this, you can't really, you can't spot it as well with the graph. So that's kind of the drawback. In some ways, it's the easiest because you're just typing in the function, but you're probably the most likely to make a mistake with the graph because, but let's go ahead and do it with the graph. Okay. All right. So, all right. So we'll just put in the original function. So y equals x squared. So x squared minus 5x minus 14 divided by x squared minus 4. All right, so I don't know what that window is. Let me just go to Zoom standard. All right, so see when x is approaching -2 over here, see that the hole doesn't actually show up in the graph, okay? See, if I did trace, or let's do second calc value. So second calc value, and I type in x equals -2, then it doesn't give me an answer because the function is actually not defined there because you'd get a 0 in the denominator, okay? So, so then what you hope to do after that is just see what's close to -2. So let's do trace. And then see if as you get to pretty close to -2, you're right at 2.25. Let's see, so I'm getting maybe closer still. Okay, 2.21. So as I kind of bounce back and forth here, my y value is between 2.21 and 2.25. So as I approach -2 from each side, and of course it's not exact by any means. It's just that's again using the graph. It's a little tough because we can't. You don't see the hole. But as you approach -2, the y value is, pretty close to 2.25. Okay, so then, but it's probably close enough that, like, let's say if this were a quiz question, I'm not going to have the answers be 2.25 and 2.26, and, they're not going to be that close. So it's probably close enough. Okay. All right. Any other questions on this one? Okay. All right, the limit value. A function can have a limit as x approaches a number, even though it is not defined at that point. So even though, just like in the last example, even though we plug in the point and it's not defined, it can still have a limit there. And that is very important. That we don't just plug in the number and say, oh, it doesn't exist or something like that. Okay? So here is we're looking at the limit as x approaches 1. Here, the y value, it's not defined there, but the limit is still 2. Here, the y value, the function value at x equals 1 is defined somewhere else. But that doesn't matter. The limit is still going to be 2. And here, the f of 1 is 2. But all three of these, as x approaches 1, the limit is going to be 2. Okay, so it doesn't matter what happens at the point. But except that if the function is defined at the point there, then that's going to be the easiest one. Okay, so practice 2. Write a function that has a limit as x approaches a number, but that is not defined at that point. So see if you can dream up a function like the ones that we've just been doing that's not defined at a number, but the function exists at that point.
I don't understand how you find out the function.
Okay, so what makes a function not defined at a point?
At 0?
When you have a 0 in the denominator.
Yeah.
Okay. So give me a function that, like, let's say if you plugged in 2, you would get a 0 in the denominator.
Okay. Like 2 squared minus 4.
Okay. So if you had, we'll say x squared minus 4.
Oh,
Okay.
that's why.
And so then if we plugged in 2, all right, so, okay, so x squared minus 4, see here, this one is plugging in negative 2, but you see, if I plugged in negative 2 here, I would get a 0 in the denominator. But I could factor and cancel that x plus 2 and make it go away. So like here's one where if you plug in 5 into this function, you'd get a 0 in the denominator. But see, I can cancel that factor that makes the 0 happen in the denominator so that it goes away. Okay, so let's see, where you had, so if where you had x squared minus 4, okay, the limit of x squared minus 4, if you wanted to approach positive 2, then to satisfy this problem, you would want it to be, x approaches 2. You would want it to be x minus 2. Because see, then when you plug in 2 here, then you'd get a 0. Okay? That make sense?
Yes, thank you.
Okay. All right. Okay. So now, limits of special functions. The limit of the identity function as x approaches a number. Well, see, the identity function is y equals x. So as x approaches a certain number, what do you think the limit's going to be for the identity function? As x approaches 5, what's the y value?
5.
5. As x approaches 3, the y value is 3. So for the identity function, the limit is whatever that number is. So as x approaches a number, the limit is a, that number. So whatever the number is, if x approaches 7, the limit is 7. Now, the other special function here that we want to look at is the constant function. The constant function is a horizontal line. So whatever x is approaching, the y value is always the same. So the limit of the constant function as x approaches a number is what?
Whatever y is.
Whatever y is. So whatever that constant is. Whatever the k is, constant. Whatever the y value is. All right, so try these problems here. All right, so Rhett, what is the limit as x approaches 4 of x?
4.
4. Okay? Because that's the identity function. All right, so Rhett, what's the second one? What's the limit as x approaches 4 of negative 6?
Negative 6.
Negative 6, because that's a constant function. So, good job. So you can think of it this way too, is if you can plug in in place of x, if you can plug in the number and it works out, then that's what you do. Just plug it in. But see here, there's no x to plug in. So the answer is just negative 6. So you can think of it that way too. All right, so 3 reasons that a function may not have a limit, okay? Number 1 is if the function jumps. Number 2, it grows too large. Number 3, it oscillates. Okay, so here's an example of each of those. So along comes this graph, and then all of a sudden there's a jump in the graph. So then right there where there's a jump, the function does not have a limit. All right? Over here, the function grows too large, goes to infinity. Or even here, goes to negative infinity. So at x equals 0, this function has no limit. All right? The third one is x approaching 0 from the right. All of a sudden, it starts to oscillate. So that means it just goes up and down wildly. So it doesn't ever settle on a number. Just keeps on going. And so we say that the limit does not exist there. Okay? So it oscillates. All right. So what is the behavior of each function as x approaches 0? So this first one is the greatest integer function, then 1 over x, and then sine x. Okay, so if you need to put these in the calculator to look at the graph, fine. Or if you know kind of what they look like, you might could answer that one. All right, so Hannah, what about the greatest integer function? What does that do at x equals 0?
It jumps. So
It
there's
jumps.
no limit.
It jumps. Okay? So to say that the limit doesn't exist there at x equals 0, as x approaches 0, okay, this little backwards e is the mathematical symbol for there exists. And if you put a slash through it, then that's the symbol for does not exist. Okay? Now, a lot of books, a lot of math teachers will put D and E for does not exist. The limit does not exist. I personally like this symbol there. Okay? All right, the next one. All right, Chloe. What happens as x approaches 0 for the reciprocal function, 1 over x?
Does it grow?
Okay, yeah, it grows infinite. Goes up to infinity. So it goes infinitely large. So again, the limit is not going to exist there. So it grows too large. So good job. All right, now, the last one is a trick question. I'll just warn you right now. So Hannah Z. What about sine x as x approaches 0? What do you think about the limit there?
So I push the
I don't really know.
Okay, so go ahead and put it in your calculator. Okay, so the sine function, graph it for me in the air if you've got it. Okay, there you go. All right. So what happens at that function? Where is the y value when the x value is 0?
0.
It's at 0. So the reason why this is tricky is, yes, it does oscillate. It does go up and down, but it doesn't oscillate so much that we can't tell that the limit is 0. Okay? Because it goes right through the origin 0, 0. Okay? So the limit does exist and it's 0. So even though it oscillates, it also doesn't oscillate enough that we can't figure out that limit. Okay? So Hannah, does that make sense? Can you see that on your graph? Or do you want me to put it up on the board?
Oh,
Yeah, it makes sense.
Thanks.
Okay.
thank you.
Okay. All right. Okay, so now these are the limit laws in your book. And I'm going to just say right now that that what I would like you to do before class tomorrow is just copy those down on the paper. And let's see, they're in 2.2. So this is on page 51. Okay? So page 51, I would like you to write down the limit laws. Basically, as we go through, the reason why I'm not going to make a big deal out of these is because the limit laws all work the way that you think that you should. So if we're going to add two functions together, we just take the limit of each and add them together. Or subtract them, multiply them, divide them, take the square root. There's nothing really tricky about any of these. So I'll just have you copy those down from page 51 into your notes. Okay? So let's actually show you what I mean by they work the way that you think that they should. So like here, if we have the limit of a function and it has 3 terms, and you're taking the limit as x approaches any constant, okay, then what you do is you just replace that you can do it separately. Now, you don't have to write this down when you're doing limits because it's kind of obvious that it works. That you don't have to, but what you're doing is taking the limit term by term. But what you can do actually is just replace whatever this number is, whatever the constant is, you can just replace x with that constant and then work it out. Okay? All right? So go ahead and try practice 5A. All right, so Joran, what do you think? What'd you get, Joran?
So I put in 2 for x, and I
Yep.
got 13.
Oh, let's see. Okay, you should have got 21. Let's work it through. So 2 cubed is 8. 4 times 2 squared, so you get 4 times 4 is 16, then minus 3. So then that's 24 minus 3 is 21. So you just made a little math error somewhere. Okay? All right, so we'll pick it up from there tomorrow. We're just kind of practicing with these limit rules. So write that down. And then St. John's, I'm going to go ahead and set up your quizzes for right now. So
And our first 2, right? For Wednesday?
and your first 2, I think, are all ready to go.
Okay, thank you.
Okay? All right, you guys have a great day, and we'll see you tomorrow.
Thank you.